Hi guys. So we're going to look at an example today of how we can use an unmanaged, unordered list to manage courses that a student takes to fill degree requirements. So this is going to be an example of how you can use lists. So we're going to have a course class that represents a course which may or may not have already been taken, program of study course that manages a list of course objects. So the list is stored for later use using serialization. So if you I don't know if you've seen serialization at this point. It's not really something I think I'm gonna test you on, but serialization, if you make an object serializable, then you can persist it to disk or a database or wherever you want to persist it. Basically, it allows you to sort of save it like you can save the object as sort of like in sort of like a text format that you can then later. So let's say we build an object, a course that represents a course, and we put a bunch of students in it, we put a bunch of other things in it, and then later we want to save that, like we want to save it off somewhere, and we could save it to a database, or we could put it in some a course, we can put it in some text file format. But another thing that we can do once we've got it in memory, we've got the classes all laid out, is we can just serialize the class itself and save it off into a file. And then later, when we want to reload that back into memory, we can just deserialize it and pull it right back into memory, and create the classes, the objects that we had before. So we can take an object that's in memory and we can save it to disk, or send it over the network, or whatever we want to do with it, and then on the other side, when we want to recreate it, we can use that information to recreate the class just like it was. And this is automatic. This is done underneath by the JVM for you. There's some, if you want to have an object be serializable, there's a couple of constraints. The first one is that the class that you want to serialize needs to implement serializable. So you see it in this slide. They have this thing, it's labeled as serializable. That means that we're going to be able to save this thing off. The second requirement is that anything that's an object inside that's not a primitive type, that's not not an integer or a float or something like this, any of your classes, they also have to be serializable. So if you want the program of study, for example, to be serializable, then this list would need to be serializable too. These courses would need to, basically everything needs to be serializable, or it's not serializable. I mean, if you think about it, that makes sense, because how can I recreate this program of study class instance, an instance of this, if I can't recreate courses or lists? Like it just doesn't make any sense that I could do that. There's a way to get around that. You can list things as transient, and then they just won't have a value and they won't get saved. But in any case, for our purposes, when you see a serializable, that's what it's going to mean. When you're talking about serialization, that's what we're going to do. All right, so let's look at our class. We have our program of study tester. So we have our main. It's going to create a bunch of classes, and it's going to put the grades. This is a pretty good student. He got an A- in Intro to Programming. For some reason, he's taken building analysis and German. No idea why, but in any case, it's a broadly interested student. So here we're going to have a function. We're going to be able to find a particular thing in the program of study, and we're going to be able to insert, so add courses after. So this is our driver program. It basically just creates and populates our program of study, and then it saves it off using serialization. So everything is implemented in classes. We can't really see what these things do, but let's go and take a look at our program of study class. So program of study implements iterable, which we'll talk about in a bit. But it also implements serializable, which is the thing that lets us save. It has a list of courses, so this list referenced here. And if you look at our implement in our constructor, when we implement this, when we create one of these, we use the linked list. So we could use an array list, but in this case, they've used a linked list, and it's a linked list of course objects, right? So here is our code to add courses. So we just call list.add. That adds the course to the end. So this is our find. You pass in a string prefix, a number, and we're going to loop over, iterate over Our list, I'm not sure if you've seen this for loop structure. This is actually pretty similar to like a Python style structure, but in any case, what this does is just goes through the list. It searches through the list and it finds a prefix equal to course.getPrefix, and the number equal to course number. So it's basically it's going through the list and it's looking for this prefix and this number in the list. Okay. And it is going to return the course when it finds it. All right, so here is our another function, which is the add course after function. So we're going to have a target course and a new course. So if any of the things are null, we're going to throw that away because that doesn't really work. We can't compare null and null. So here we're going to get the index of target. So we're going to find the index. So this is an index list, or we're using the index aspects of the list rather. It's kind of a wonky data structure, to be honest. So here we're going to get the index. So this is like the index list that we're talking about. We're going to get the index of this thing. So if this can't be found, it's going to return a -1. If it doesn't find it in the target, it's going to return a -1. That's like the error indicator. Again, why does it do that and not throw exceptions? I don't know. But then we're going to add list.add target index +1 new course. So we take the card index, we say we're going to add it one position past the course that we found. All right. So that's the add course. Here's the replace code. Again, it checks the thing, see if these things are null. We find the target using the same index of operation that we used before, which returns the index in the list of this course object. So if the target index is not 1, meaning that we found it, we're going to set the set function sets the element equal to this new course. So we use the index and the new course that we want to replace it with, and this just replaces the old one with the new one. So we have a toString implementation, as we seem to like to have. So we haven't talked about iterators yet. So let's just sort of skip this because we're going to talk about this in the next section. We'll talk about iterators. They're just sort of using it here. This is required for some of the stuff that they're doing, but don't worry about this yet. We'll talk about this in the next chapter, what iterators are. So here we have our save function, which throws an IO exception. So we're going to make a file output stream, and here we're going to use the serializable, right? So we're going to create a file output stream with a file name. We're going to create an object output stream, and we're going to pass in the file output stream that we're going to write to. So this is our object output stream, and this is just a standard class in Java. You see it up here in java.io.object output stream. And what this is going to do is this is a piece of code that will serialize an object. So it's going to convert the object to a text format or to a binary format, a format that you can write to a file. It's going to take it out of memory and pack it down into like a binary array, and then it's going to write that out to a file with some information in it about the type, the class, and what the different field values are, and the types, and all this other information. So then we can just call write. We can write this object out using this object file stream, and the object, this is the this pointer, so it's the current object, and this current object, of course, is serializable. Oops, where are we? And then we're going to call flush to flush the buffer, and then we're going to close, right? So this is just writing this object out to a file, and if something fails, it's going to throw an IO exception. If any of this fails, it's going to throw an IO exception. All right, so this is, you probably haven't seen this yet, but this is basically, it's a pretty standard thing for people to do when they want to save something that's in memory out to file. You can do lots of interesting things with this. All right, so here is the load where we take a string name and we basically do the opposite of that. We make a file input stream, we build an object input stream, we pass in the file input stream to it. We create a program of study object, and then we're going to cast this thing and call read object from this file. you notice that this throws a class not found exception. So when we serialize the class, we're going to put information about the name of the class and the type. And if it doesn't match what we try to cast it to, so that, remember that this OIS is this .read object is going to return an object type, right? So basically, this is a base class for Java. We're going to try to cast it up to a program of study class, and that may fail or may succeed. So if it fails, it's going to throw a class not found exception because the thing that we read in was not a program of study type object. It's trying to enforce type safety on these things. Otherwise, I mean, if you just use binary, then it could be anything in there. The type safety means that what you get back is what you think you've gotten back. In any case, if you haven't seen this before, this is kind of interesting. Some fun stuff you can do with this. All right, so here is our class course. And again, as I mentioned before, if you want your class to be serializable, everything in your class must be serializable. So courses must be serializable because this is in the list, and of course the list is serializable. These things are all base types, so they don't have to be serial. They're serializable by default. So we have our course, which has these properties: prefix, number, title, grade, which can be empty. We can get the prefix, get the number, get the title. This is pretty straightforward. These are just getters and setters, right? Here is our comparison to see if these two things match. So we're going to look at the course prefix and the course number to decide if these things match. I guess the assumption is that the person has only taken a particular course one time, because that's what they're using for their comparator here. Here's our toString to convert it to a string. All right, so again, serialization. So if you have a class and you flag it as implementing serializable, then it can be serialized. There's no method that you have to implement. It's done internally by the JVM. But every internal class also needs to be serializable unless it's a base type. So there you go, serialization. Here is the UML diagram for all of this. If you want to go through this, we have a linked list course, which implements the list interface. Our program of study stores all of our courses in this linked list or in this list. Here's our course definition and our tester. All right, so we're going to look at another example of how we can use lists. So we're going to look at the Josephus problem. So we have a set of elements that are arranged in a circle, and we're going to start with a particular element, and every ith element we're going to remove. So we're going to start on a particular one, we're going to hop, 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 and then when we get to I, we're going to remove it. And we're going to keep doing that until there's only one element left. So given the starting point and a remove count, I, which element is left? So this is the question that we want to answer. So we're going to implement this with a linked list, an index linked list. So here's our class for our problem, this public class Josephus. Got our main, this is our driver. So what are we going to do? We got number of people, we got the skip, we got the target index. So it's the number of people in the list, the skip, the I that we're going to use, and then the starting index, basically. So we're going to make a new list. It's going to be an array list. Array list is particularly nice. You can kind of imagine why I might want to do this. I haven't looked yet, but I have this feeling we're going to see our old friend, the modulus operator. Let's take a look. So we're going to get the initial number of soldiers, and that's going to be equal to the number of people. Or we're going to read this in. We're going to get the number of soldiers to skip. We're going to add the soldiers in one at a time. We're going to have our target index is equal to our skip. And then we're going to print this order. So we're going to treat the list as circular, right? And we're going to remove every nth element. So we've already seen how to do circular arrays, right? We saw in the last chapter how to do circular arrays. So basically, we're going to say target index equals target index plus skip mod list size. So we're going to mod the list size, which means what that's going to do is, remember, we're going to be removing from this list every iteration, or every iteration of this loop, right? So we are going to start with the element, whatever specified. We're going to skip 1, 2, 3, 4, 5 I elements, and then we're going to remove that element. We'll remove that element. The list size is going to go down 1, and it's possible that we are going to go past the end of the array. So if we go past the end of the array with the skip, we need to go back to the beginning, right? Because we're going to treat it like a circular array. So we're going to mod by the size every time to figure out what the current index is with taking into account the skip. So we're going to start with the last index, the original index. We're going to say the new index is equal to the last index plus the skip, and then we're going to mod by the list size to wrap it back around, right? Because we're going to treat it as a circular list. All right. So that's the end of the lecture. It's another example of how to use lists. In this case, we use an array list. So that's the end of the lecture. We'll come back next time. We'll talk more about lists. All right. Thanks, guys.